Okay, today we're going to talk about the area between curves, and by the end you'll know that certain regions can be calculated with definite integrals, which we're going to do in a minute here. First, I want you to estimate the shaded area in the graph below and be prepared to describe your method. So I'm going to give you a few minutes to, you can pause the video and go ahead and calculate that. I'm going to do the same, and when we come back we'll talk about the solutions. Okay, so you've had a chance now to do this for yourself, and some people did this in different ways. Some people took and divided this up by this triangle here, and they said that that was 2 by 1. It was 1/2 times 2 times 1, which of course is just 1. The area of that triangle is 1. And they said, you know what, I can treat this as another triangle and I can get a fairly good estimation. That triangle would be 1/2. It's half of the square there, that's 1. So they said about 1.5. 1.5 would be a slight overestimate. Okay. Other people did it different ways, like some did this. They said, you know what, I can do a trapezoid from here to here. And they said this would be 1/2 times 2, oh sorry, 1/2 times 1, the height is 1. 1/2 times 1, the base here is 1, and then, or the height of the trapezoid, and then base 1 is 2, plus base 2 is 3. And then they said you then have to subtract off that triangle, which is then, so this would be 1/2 of 5, which is 2.5, and then subtract off the area of the triangle. You also get 1.5 that way. Both those are acceptable ways of getting an estimate. Now you might, if I'm using the trapezoid method, I might make 2 trapezoids and then subtract off the area of the triangle to be a little more exact. But if I told you that this top function here is the top is y equals x squared plus 2, and this bottom function is y equals 2x, and then we can see that it also has a left bound, or sorry, a right bound. This is a right bound, not a left bound. A right bound at x equals 1, and then on the left it's at x equals 0. So I can do area under a curve with integrals. So if I were to do that, it would be the integral from 0 to 1, and some people did it this way. They did x squared plus 2 dx, and then did minus the integral from 0 to 1 of 2x dx. So they did one integral would give you the area under the top curve, and a second integral would give you the area under the bottom curve, and then you subtract. Another person did this, the integral from 0 to 1 of x squared plus 2 minus 2x dx. And the reality is those two things are exactly the same thing. They're exactly the same thing. So we don't have to differentiate. You can do it either way. I would obviously do the one where it was one integral, but that's how it's done. So let's talk about area between curves. Okay. The area bounded by y equals f of x and y equals g of x, and lines x equals a and x equals b, where f and g are both continuous on AB, and lastly f of x is greater than or equal to g of x on AB, then that is given by, that area is given by the integral from a to b f of x minus g of x dx. And we can do this when it's when they're in terms of x. It's the integral of the top minus the bottom. And when it's in terms of y, it's the integral. We usually use c to d for when it's in terms of y, but it's the rightmost function minus the leftmost function in order to find that. So let's look at some examples. Okay. Find the area of the region bounded above by f of x equals e to the x, bounded below by f of x equals x, and bounded on the sides by x equals 0 and x equals 1. Well, I want to sketch this graph. So I'm going to bring in my calculator and I'm going to graph it so I can see what this looks like. Okay. So I'm going to turn my plots off first of all. Clear this out, and I want e to the x. And then I want x. And I'm going to change my window because it says x. It says x goes from 0 to 1. And let's just graph that and see what that looks like. So there's the e to the x function right there. And there's the y equals x function there. We got a lot of space there. I'm going to change the window. Let's make it go from 0 to 5. Okay, there's the first function. And the second function, so I can see I have a little curve on top, a line on the bottom, and then these are cut off. This is where it ends. They don't intersect here, so I'm going to draw this graph. And the calculator is going to disappear here, so that's okay. It goes like this then. Here's my curve, goes like this, and then it goes like this, and there's a sketch of my graph, and this is the region R that we want the area of. So we said this is y equals e to the x, this is y equals x, okay. And this is 0 to 1. So we'd simply make an integral from 0 to 1 of e to the x minus x dx. If we calculate that with our calculator, we get 1.218. Now if we do that non-calculator, we would take the antiderivative, which would be e to the x minus x squared divided by 2, evaluated from 0 to 1. And then I would plug in e to the first minus 1 squared is just 1, so 1/2. That's plugging in 1. And we plug in 0, e to the 0 minus 0 over 2, so of course that's just going to be drop out. E to the 0 is just 1, so what I have is e to the first, or just e, minus, and this is just 1, so it's minus 1/2 or minus 3/2. Non-calculator, you would leave your answer like that. You wouldn't try to put in 2.718 or anything like that. You would leave e in your answer, and that's okay. Alright, so let's look again at another one. Determine the upper and lower functions and side bounds. Now in this case, they don't tell us where to stop on the left and the right. We always need a top, a bottom, a left, and a right. And they didn't tell us that here. So we have to determine that, and we can determine that a couple ways. We can graph it and find them graphically, or we can just know that x squared and x cubed have to be equal. Well, there are two spots where that's going to happen, at 0 and at 1. Those are the only spots where x squared and x cubed are going to be equal to each other. Well, let's graph it, see what it looks like. So y equals x to the third, and then x squared right here, Okay, and then zoom 6. So we have a standard window. And I can see there's something going on in the middle here, but I need to zoom in on that. So zoom in. And there is a little space in there, so I'm going to know they intersect at 0 and 1. I'm going to go from 0 to 1. And I'm going to go from 0 to 3. There's the first one, and there it is. There's our region. Okay, it looks like x squared is on top this time, so this would be the integral from 0 to 1. X squared is on top minus x cubed dx. And you can put that in your calculator to get an answer. All right, let's do it again. Now this time our functions are going to be a little more difficult. We're not going to be able to solve this. We can't set those equal and solve. We're going to have to use our calculator to find these intersection points. So let's put these in. So it would be, let's put a fraction. It would be x divided by the square root of x squared plus 1. Our first one, and then the second one is x to the 4th minus x, so x to the 4th minus x. Let's zoom 6 so we get a normal window here and see what that looks like. There's our first function, there's that fraction, there's the second. We can see there's a region there. Let's zoom in on that region. So now we can see the region well enough. It looks like one of their intersection points is at 0. So let's find that out. Second trace, let's value at 0. So 1, and then put 0 in. Equals 0. They both equal 0. So 0 is one of my intersection points. That's going to be part of it. Now let's find the other intersection point right here where that is in the calculator there. So second trace, number 5 for intersect. First curve, second curve, and guess we just get it nice and close to this intersection point. Enter 1.1807. Okay, so my intersection points were 0 and 1.1807. I do believe. I'm going to double check that. 807. Yep. And so my integral would be from 0 to 1.1807. Now I have to remember which one was on top. Let's go back and make sure we know which one's on top. Well, this is the second function. This is the first function, is this one. So the first function is on top. So that x. So it's x divided by the square root of x squared plus 1 minus, and then parentheses, x to the 4th minus x. Put a bracket around the whole thing, dx. Again, that we put that in our calculator, we get to about 0.785, and that would be our answer. Okay. So there's our first several examples of this. We're going to do a second day. We'll give some more examples later. This is part 1.